Okay, the two problems that I'm looking over here that might be easy to do is problem number one, including if I get it wrong, by the way, it's going to be quick. Number two looks sort of reasonable. We'll talk about that. Number three looks a little bit tricky to me. Number four looks a little tricky to me. And number five looks like it's going to be a tough problem. Like you have to know something about the sums of a series for that one there. That's a little bit tricky. So let me just do number one first, all right? Now, again, they give me a picture, and I'm kind of thankful because I don't have to waste my time about that picture. My pictures don't look that good anyway. The machine drew this picture, by the way. I'm going to trust it. So really what they're asking is, when does this function here, let me outline what I mean by that. When does this function here, I did it again, when does this function here equal that function over there? Right, so what I would need to do is I would need to draw that root function in and find out where they agree. All right, so I'm gonna plot points, certainly here. And then I'm doing this over here, y equals the root of x. And I'm only doing easy numbers, by the way. So what's the next one I'm going to see? 1, 1. That's about here. What's the next one I'd see? 4, 2. About right over here. Now, granted, I could definitely trace that in right now. So I know there's a point of intersection here. By the way, they're not asking for the point of intersection. They're saying how many. Now, what's the next easy number? That would be 9, and 9 would be giving you 3 over here. So I think I could trace this in 2. And I'm seeing 2 more points of intersection over here. So one's here, one's here, one's here, and one's here. The problem I have now is the connection between this point over here, 1, 1, and this point over here, 0, 0. I realize what some students do. They do this over here. It sort of, roughly looks right, but you're not thinking about the behavior of the sine and the behavior of this root function. The root function is more parabolic. What I mean by that is, y squared is equal to x, which means it's parabolic, like this, all right? And the sine function is more linear, like this. So I'm going to say this thing is more parabolic over here. Now, granted, I'm exaggerating. I know that. I can't really draw a good picture. But I'm going to say there's a point over here. How many points do I have now? 1, 2, 3, 4, 5. So I'm going to say the answer to this would be 5 points of intersection. Believe it or not, most people would answer that. At least I believe most people that have some knowledge of these functions would say there's 4, all right? And really it comes from, maybe, I'm not going to say a poor understanding, but not a complete understanding of the behavior of the sine and the root function near the origin. So I want to go to the answer key. And when I do that, I want to point out they do give me a graph. They give me a graph with the root function in there. And by the way, I'm going to just, make sure I'm blowing this up over here. I'm going to use my fingers. And I'm kind of seeing that now. Again, they do a much better job of drawing than I could ever do. But I blew that up, and with my fingers, by the way. And I'm seeing those points of intersection now. Again, 1, 2, 3, and there's 2 over here, so 5 total. I also want to point out that what I did was I gave you another picture over here of that region blown up again. All right, so this is the root function, and this is that sine function over here. All right, so you have a root function and a sine function there, and near the origin, the sine definitely looks like a line, and the root function definitely looks parabolic. All right, so I'm going to say 1 was pretty easy, including if I got it wrong. If I said 4, it's pretty easy, but if I got 5, I got it right, and maybe you could certainly I write down in the narrative what I'd like the student to answer. All right, so I'm going to look at the number 2 now. Let me start to erase this over here. And I'm going to erase all this business over here. I'm going to do number 2. And number 2 looks a little bit tricky. It's an integration problem. The integrand is defined for all real numbers, but I'm starting to realize the degree of the top is 8, and the degree of the bottom is a square. So I would say long division's in order. Now, for me to do long division, I'm going to have to multiply it out, all right? So I would need to know the binomial theorem to do that. And let me just remind you, what a lot of students do, they just write Pascal's triangle down. Nothing wrong with that if it's a small number, which this is. 4 is a small number. All right, I think I can expand this out. Let me write this down for you. So it's going to be x4, and I'm expanding out the 1 minus x to the power 4. So it's going to be 1 minus 4x plus 6x squared minus 4x cubed plus x4. Now what I have to do is multiply that. What do you get? x4 minus 4x5 plus 6x6 minus 4x7 plus x8. Now I'm going to do my division. And the division, I'm going to take x squared plus 1, and I'm going to divide into the top. And that's the reason I expand the top out, so I could do the division easily. I'm going to write in proper order, though. x8 minus 4x7 plus 6x6 minus 4x5 plus x4. And I'm hoping when I do this, I get an integrand that's easier to deal with. If not, I took a wrong path, and I'd have to back up, all right? And that can be very costly on a timed exam, by the way. So let's make sure everything's looking okay here. And yeah, it looks okay. So what times x squared would give you x8? That would be x6, right? So what do you get? x8. And then you'd get plus x6. Well, I'm going to subtract. That's minus 4x7. And then you can get plus 5x6. I like to drop all the places down, by the way, because otherwise I tend to forget things. And what do you get now? I'm going to say minus 4x5. That's going to give me minus 4x7 minus 4x5. Let me subtract. You get 5x6 plus x4. I'm going to keep going. And what I'm going to get plus 5 x4. What does that give me? 5x6 yep, plus 5x4. I am going to subtract now. What do you get? Minus 4x4 minus 4x squared. What do you get there? Minus 4x4 minus 4x squared. Well, let's keep going. What do you get now? 4x squared, right? I'm just going to look at my division again, because it seems like it's going on a pretty long time here. So let's see if I wrote down everything I need to write down. 1 minus plus minus plus, x4 minus 4x5, 6x6 minus 4x7, x8. Let's see if I did the x6 right, x8. And then you get, I'm taking a look at my work, that's all I'm doing, make sure I got everything right. And minus 4x7, five x6, minus 4x5. I'm just going line by line, by the way. And you should do this too when you're doing things, because you're looking at something, which, am I going forward in the right direction? 5x6, x4, 5x4, 5x4, minus 4x4, minus 4x4. Yeah, I think I did okay. Let's keep going. What's the next thing going to be? Plus 4. And let's see what you get there. You get 4x squared plus 4. So what's my remainder? My remainder is minus 4. Wow, that's a lot of work. Let's hope this really is productive, by the way. So someone says, what do you mean productive? I want to see if I can do the integration. And I'm gonna have to start to erase things. I realize that, I'm doing this on a tiny little whiteboard, and I'm just gonna erase this business up here, by the way. I'm gonna keep my division there. I'm gonna erase this up here. And I wanna write the integration down. All right, so this question is, what is the integration? So I'm gonna put an equal sign over here. I'm gonna say the integration is gonna be 0 to 1. And I get this. I get x6 minus 4x 5 plus 5x4 minus 4x squared plus 4 minus, there's a remainder, right? Minus 4 over x squared plus 1 dx. Well, the integrand has been rewritten, and what I notice about the integrand now is I can actually integrate this quite easily. All right, so let's write this down, and I'll be very careful. You get x 7 over 7 minus, well, that's going to be x6, right? And then what do you get? When you divide by 6, 4 divided by 6 is 2/3. Then the next one's going to be plus, well, that's going to be x5, and when you divide by 5, the 5 disappears. Then you're going to get minus 4/3 x, I'm sorry, I made a mistake there. X cubed plus 4x. And I hope you recognize the last guy as being a very easy antiderivative. And that's going to be minus 4 arctangent. Limits integration go from 0 to 1. All right, I got to do the arithmetic now, and it doesn't look that difficult because 1's really easy to do. I mean, maybe not easy to do, but I could write down 1/7 minus 2/3 plus 1 minus 4/3 plus 4 minus 4 arctan of 1 is pi over 4 minus the lower limit, and everything in the lower limit, every single term, including the arctangent, is going to be 0. So I got some arithmetic to do. I got 1/7. I like to do things that are easy for me. Minus 2/3 minus 4/3 is minus 6/3. Minus 6/3 is minus 2. And this is minus pi. Let's keep going. So I got 1/7 plus 3 minus pi. I'm going to add the 1/7 to the 3, and that's going to be a common denominator of 7. And you can get 1 plus 21, which is 22, minus pi. Again, I got to the end, but the bottom line is getting to the end. Am I right? Well, when a competitive exam, walk away, right or wrong, walk away. Get to the next question. But let's take a look. 22/7 minus pi. All right, we're okay. And you can look at the work if you need to. All right, so I'm going to say I'm done with this. All right, so I did 2 problems. And, pat yourself in the back if you got 2 out of the 5. All right? It's not a bad thing to be saying. It's better to get, 1 than none. Better to get 2 than 1, so forth and so on. But I didn't think that it was tedious, but it really wasn't that bad. Let me just erase all this business up here. And I want to kind of move on. I'm going to move on to number 3 now. And number 3 says, f and g are defined for all positive numbers such that this is true and that's true. G of 1 is this thing. Find f prime of 4. By the way, such as I'm making is that I can actually find f prime of 4. In other words, the function is differentiable. Well, let's take a look at it. And let's write it down. So what do you get? F prime x squared. I use chain rule, right? That's going to be 2x. And this would be 3x squared. So what would x have to be to get f prime of 4? X would have to be plus or minus 2, right? Let's do 2 first. So what do you get? F prime of 4 times 4 equals 3 times 4 is 12. So F prime of 4 would equal 3. You know what? Let's try minus 2 now. Let's see what happens. F prime of 4, right? And then what do you have here? Times. Let me take a look at that. That'll be minus 4, right? Equals. It's going to require some thinking here, isn't it? Now it'll be 3x squared, which would be 12. So I get 2 different numbers. I got to think now, right? What's that going to give me? Minus 3. I got to think. And the problem with thinking is it wastes time to think right now. Let me do this. U equals x squared. Let me just read that again. Oh, this was a reading issue. I want to point out, I'm glad I read it. All positive real numbers. So what I can do now is I can erase my confusion. It can't be negative. All right? So I'm going to say f prime of 4 is 3. I'm glad I read. Because otherwise I have to start thinking about that. Is it possible to get 2 numbers? It's functional, by the way. Here's the deal. I got to do the next one. I got one down. I got this one down. Let me do the next one. And I want to point out that g prime of x squared is equal to x cubed. But you know what I got to do? I got to integrate. And the problem with integrating is not the right side, but it's the left side. And in order for me to integrate the left side, I really need to get like a u substitution going. If I did a u substitution, it would be u equals x squared. But then I would need to see 2x in the problem, and I don't see it. So I'm gonna install it by multiplying both sides by 2x. Again, this looks like an integration problem to me. So I'm multiplying both sides of the given by 2x. And what would you get over here? You would get g prime x squared times 2x equals 2x4. I'm going to do my integration now. And the integration is going to be this. G prime x squared 2x dx equals the integration 2x4 dx. All right, the left side's pretty easy to do. Again, if you want to do u substitution, you can. Yeah, u equals x squared, and du would be 2x dx. So it's going to be g prime of x squared. You can check that, by the way, if you want. I'm sorry, I didn't mean to say that. It's g of x squared. So that would be g prime x squared times 2x. It worked out beautifully. Now, by the way, there's going to be a constant somewhere, and we'll talk about that later. I'm going to integrate the right-hand side, and that's going to be what? 2x 5 over 5 plus some constant of integration. So let's go back over here. And what was their question? They want to know what g of 4 is. So I got to pick something. I got to pick, g of 2 squared. So I'm letting x to be 2. Again, the x have to be positive numbers. So that's going to be what? That's going to be, x is 2. That's going to be 2 times 2 to the 5th power, 2 to the 6th power, right? 2 times 2 is 4, 8, 16, 32, 64 fifths. Unfortunately, I got a C. I don't know what C is. So I got to go back and say, did they give me anything else? And they did. They said G of 1 is 0. So what does that mean? Well, G of 1 is equal to 0 basically tells me that X equals 1. So I'm gonna use that relationship. I think I can find the C now, right? So you can get G of 1 is equal to 0, and that equals 2/5 plus C. What's the C have to be? Minus 2/5. So I'm gonna write that down for you now. The C has got to be minus 2/5. So what's G of 4? It's gonna be 64/5. We just did up here, plus the C, which is minus 2/5. So 62/5. Let's look at the K, and I want to see if f prime of 4 is 3. I got this. And the other thing I want to do is I want to see if I got this one over here. And that's G of 4 is 62/5, right? All right, we're doing okay. All right, get me an eraser out. I'm going to start to erase. I think we did okay with that. Now we just did 3. Now, the other ones are, I'm going to say, more difficult. Now, be aware of this. On a competitive exam, you know, not everyone's going to get every single question right. And it depends what your competitive audience looks like. And what you start to realize is the more effort you put into this, the easier these problems will become for you. So I'm going to say 1 was quick. Even if I got it wrong, it's quick. 2 is quick, right? If I realized long division was involved there. Again, you may say I have better ways of doing these things, and certainly it can't hurt to share it if you got a better way of doing something. This one wasn't so bad. You know, I got the numbers and stuff. This one really wasn't so bad. I got to be honest with you, this was a little bit tricky, though. I needed to know something about the antiderivatives and U substitution. I want to do this one over here. I want to point out, looking at this thing over here, they kind of mix letters and stuff, right? So one of the things I would do is just kind of see if I could just rewrite the problem, right, with the letters that they're using. So let me put this over here. Do I know what F is? I do. It's right over here. So I want to write this down. And the way I'm going to write it down is I'm going to use the N letter now. So it's going to be N plus 1 over, because I see a negative power over there, and that would be 2 to the N plus 1. And then the bottom is going to be 2 minus, well, this is a bit more tricky, isn't it? And I want to see if I can do these things. And by the way, I'm hoping that there's a pattern to it. All right, so let me write this down for you. So what's F of 0 going to be? That would just be 0, right? And again, I'm hoping I see a pattern. What's the 1 going to be? It's just going to be 1/2, right? What's the next one going to be? Well, that's going to be 2 over 2 squared. Now, someone says, why aren't you doing the arithmetic? I'm just looking for a pattern. The next one's going to be 3 over 2 cubed. I think you get the idea. Yada, yada, yada. And it goes up to, well, that would be n, right? Over 2 to the n. All right? I got troubles. That's a sum. I want to write the sum down, though. I'm going to write down Sn. I'm just writing the sum over here. And what's that look like? It looks like 1/2, right, plus 2 over 2 squared plus 3 over 2 cubed plus yada, yada, yada plus n over 2 to the nth power. And I'm kind of looking at that, and I'm wondering, what would I do to get that to work nicely for me? I do want to get that sum. And I'm going to multiply, let me see what I'm going to multiply by. I think I can multiply by 2 at first, see what happens. Well, you would get 1, and then you'd get plus 2 over 2 And then you would get 3 over 2 squared plus, I think you get the idea. I'd keep going, right? And what do you get over here? N over 2n minus 1. Again, that may not be helpful, but I'm starting to realize that I see something. Like I notice this over here. Let me put a little red line in for you. I'm looking at the denominators over here. You get the idea? And by the way, there would be 1 before this one over here too. All right. Now someone says, why would you do that? It looks like maybe a subtraction might help me to get rid of a lot of things, or maybe no things at all, right? And let me write this down then. And let's see what I get. And I'm looking at it. And I get minus Sn. Oops. Keep doing that, don't I? And let's see what you get. Again, I'm taking this, subtracting this. So I get minus 1 minus, by the way, that minus 1 comes from here. That would be 1/2. Right? You see that? What's the next one going to be? Minus 1 over 2 squared. What's the next one going to be? And I'm doing this one, and that would be a 4 over 2 cubed. That would be minus 1 over 2 cubed. I'm going to keep going down, minus dot, dot, dot. And then over here, I get minus. I want to point out there's a term here, and that term there would be n minus 1 over 2 n minus 1. And if I did that subtraction, I'd get 1 over 2n minus 1 plus n over 2n. All right, let me multiply a minus 1 across both sides. And what are you going to get? Sn is going to be 1 plus 1/2 plus 1 over 2 squared plus 1 over 2 cubed plus, I hope you recognize being geometric, by the way, 1 over 2n minus 1 minus n over 2n. By the way, I want to simplify this. All right? So let me just remind you that to do that sum, and again, I'm just doing this sum over here. This looks like a simple geometric sum. Let me just call this thing, I'll call it just S in general, okay? And this is going to be 1 plus 1/2 plus 1 over 2 squared. And if you know the formula, that's fine, by the way. There's nothing wrong with knowing things. Multiply both sides by 2. Boy, this is familiar, isn't it? What do you get? 2 plus 1 plus 1/2 plus yada, yada, yada. 1 over, that would be multiplied by 2, n minus 2. And if you did this thing, I'm going to subtract over here this way, by the way. This would give me S. And what do you get? Well, I want to point out there's a lot of disappearing x over here. And this would disappear over here. And what are you going to get over there? Well, you're going to get 2. Again, I'm doing the subtraction over here like this. And then minus 1 over 2 to the n minus 1. All right, so let's write this down now. Sn is actually equal to 2 minus 1 over 2 to the n minus 1 minus n over 2 to the n. All right? So that's not so bad. I mean, we did a lot of work there, but the question is, that might have been unproductive work to do. And, what I have to do now is, I got the formula. Let's just go to the next page and show you they did that work over there. And I did a lot of work. And I think well, let me write down GN, see if we match their GN, by the way. I got to write my GN down again. And the bottom turned out to be, again, I got the SN. I call this the SN, so it's 2 minus that thing. So 2 minus this thing over here. The bottom would be, let me write this down for you. So G of N. Again, we just did the SN in the bottom. Again, this was the SN. 2 minus this thing is going to be 1 over 2n minus 1 minus n over 2n. That's the bottom now. And what was the top, though? Oh, n plus 1 over 2 to the n plus 1. Let me multiply top and bottom by 2 to the n plus 1. This is work, isn't it? And what do you get? Gn equals n plus 1. And I'm going to multiply the bottom by 2n plus 1. And that's going to be n plus 1 minus n plus 1. And the n's cancel off, and you get 2. So that's going to be 2 squared, which is 4, minus n, and that would give you 2. All right, so I get a nice easy formula, n plus 1 over 4 minus 2n. Let's make sure we got that. Oh, I'm sorry, I copied wrong. I really apologize for this. I said I was subtracting this thing over, so this is this over here. I didn't see that. Sorry about that. So it's n plus 1 over 4 plus 2n. So I did make a mistake, but anyway, corrected it. Can't hurt to look at a key, right? So what's our question? Right, I know what G of n is now. It's really simple. That was a lot of work to get there, though. For me, anyway. What was their question? Let's write down. They want AM, right? And that's defined as being G m plus 1 over GM. Let's write that down. Well, let's see, the top is going to be m plus 2. And what's the bottom going to be? Let's see, 2, we're doing the top, by the way. 2m plus 2 plus 4 is 6. What's the bottom going to be? m plus 1 over 2m plus 4. I'm going to do some, I can't say trickery, but I got to figure this out. And it's going to be 2 times m plus 3. And I'm dividing by the bottom, so it's going to be 2 times m plus 2, m plus 1. So what are you going to get? You're going to get 2 m plus 2 squared. And the 2 on the bottom cancels. Let's get rid of that. M plus 3, m plus 1. All right, did we get that? Yeah, we're okay. And BM, what's BM going to be? It's a subtraction. Again, we've already done this one over here. And we've done this one over here. And that's going to be in a subtraction problem. I don't think I need to go through that. You can do that. All right? Okay, this one, to me, number 5, is probably the most difficult problem. And granted, I'm not saying I've done it the best way, but I do want to just briefly go through it. I realize I'm coming to the edge of the clock at this point. But what we'll do is find all the values of R, right? All the values of R. I keep doing this, don't I? They want to find all the values of R where the partial sums of the series are going to be non-negative. All right. Now this sort of looks geometric to me. All right. So the problem is these cosines in it, though. I know the cosines are going between plus or minus 1. All right. So I'm going to say if I just didn't do much thinking on it, I would just simply say this converges for all R. Whoops, sorry about it. I would just simply say, oh, geometric. I'm not giving it much thought, by the way, which is not a good idea. I would just say, oh, the R, the absolute value of the R, has to be that. It looks geometric for him, but that's giving it no thought. So they say, and I want to point out what they're saying, the partial sums. So I would say like S1 would just be the first term would be a half. That's definitely a positive. S2 would be 1/2 plus r cosine of x. Now to guarantee that this is positive, I have to start to realize that this thing here, the cosine could be -1, right? You don't know what it is. It could be -1. So what's the most the r could be? This is no good. So the most r could be now, right, would be 1/2. So I could write this down. All right? So this one, no thinking, I would have said that. With some thinking, I would have said this. Got another problem on your hand. You got the S3 in. And then you got S4 and S5 and S6. All right? So what I want to do is just briefly go through it with you. But I realize I'm running towards the edge of time over here. And, I want to point out that I did say, if I was just doing what I did above over here, that hopefully that this is clear to you. And what I mean by clear is we just talked about it. And the fact that we're talking about things doesn't mean it's clear. All right, what I mean by this, S1, I did S2, that the r would have to be that number over there. Because again, cosine could be -1. So the absolute value of r has got to be less than 1/2. All right? Got to be. All right? Let's keep going. Let's keep looking at it. And looking at it, I write down a function for you. And the function I'm looking at, there's patterns over here. I'm just looking at the patterns in the original problem, by the way. I want to point out what I'm doing over here. I'm looking at this and seeing patterns. Again, if you look at it, I think it might be somewhat obvious what you're looking at. Maybe not, though. Right? Do I see these terms up here? Yeah, I see them. R cosine x, r squared cosine 2x. Then I see this. I'm seeing them all. All right, I'm seeing them all in that problem over there. It goes on forever, though. And there's a problem with forever. When do you stop? All right? So what I wrote down next is I wrote down this pattern, using the f instead of the, those things with the r's and the cosine in it. So the hope is you can jump from seeing a simple pattern to this pattern. All right? By the way, the understanding is what f is. This is f over here. So f of x is r cosine of x plus r squared cosine of 2x. So I took the derivative of it. All right? And I get this over here. Really not that bad. Talk about the critical values of it. Got this over here. Got this thing over here. Wow, long process, huh? And I got this thing over here. You want to read through this, by the way. I know it's tough. Boy, does this thing ever stop. And I got to be honest with you. I had a tough time constructing this. There's no doubt about it. But at the very end, I came up with this conclusion over here. This took me a long road to get there. Could someone have a better way of doing this? Of course they could. And I would love to hear from someone saying, you know what? I think you're missing the point in this one over here. What you're doing, although is followable, I got a much quicker way to the conclusion of that one over there. But this was my work to get to that conclusion. All right, now, again, my intuition in the beginning was this has got to be held. By the way, this is my first intuition. Then I start to revise it one step at a time. But at the very end of this, I'm saying that this has to be the case over here. But I took a long walk there. I don't think you have to do that. Maybe some see something better. If you do, reach out. Let me know. I'll revise the answer. What's my email address? It's over here. They say the best way to get a correct answer, post the wrong answer. And then you get a billion people telling you why you're wrong. All right, here's the deal, though. I really can't say that I'll monitor emails for this video, but who knows? Maybe I will. If there's not many people emailing me, I'll certainly entertain you, right? If there's a ton of people email, I can't entertain you. There's no way I can do it. I don't have the time of the day. I work. I have other things to do. I do a lot of things. I'm busy all day long. I even work on holidays. So again, if you reach out to me, don't feel offended if I don't get back to you. Thank you for paying attention, though. And again, this last problem I found to be incredibly tedious to do. All right, I couldn't think of a better way of doing it, by the way, but that was my thinking. The beginning thinking was easy for me. Later on, it got more difficult, going down a rabbit hole, so to speak. But at the end of it, I did come to a firm conclusion that the absolute value of R had to be less than 1/2 for it to be a positive term sum. All right, all partial sums, positive term. All right, thanks again for paying attention.